I'm going to sit over here because I actually woke up with a massive headache this morning. So that's why the lights are a little dimmer today. So what we're going to do on this one is we are going to find our axis of symmetry. We are in standard form here. So to graph this, we're going to identify our axis of symmetry and put that in the middle of our table. That was not the button I meant. I was looking for this one. There we go. So we're going to start with finding our axis of, come on, pen, stop being a jerk. There we go. Axis of symmetry, where we take the opposite of B over 2 times A. So what's our B value? It's 1. So the opposite of 1 over 2 times our A. And what's our A? 1/2. It's this guy out in front right here. And this one came from here. So we wind up with -1 over 2 times 1/2. What is 2 times 1/2? 1. So -1 is the middle of our table. So when we come to our table, we're going to pick our x's, we're going to find our y's, and we put that axis of symmetry in the middle. We pick a couple of numbers bigger, like 0 and 1, and a couple of numbers smaller, like -2 and -3. Then what we're going to do is we're just going to plug those into our calculator, which means I should probably get my calculator open. So on the screen, so we're going to put it over there. So we're going to start with typing some things into the calculator. And we're going to start with -3. So, calculator time. There we go. Not 4. So we're going to take -3. Oh, hang on. Our 1/2. We got to get that guy in there. 1/2 times -3 inside parentheses, and the squared goes outside. Plus 1 times -3. Ooh, parentheses, minus 4. We have -5/2, or -2.5. Is that right? Yep. Because we took our whole equation and we substituted in our -3 in place of that x every single time. Just like that. That's what we did. I just did it in the calculator because I didn't want to have to write it too many times. That's an arrow. I don't know what that symbol's trying to be. It was meant to be an arrow. There we go. We're going to do the same thing with -2. Yeah, I see that. Thank you. There we go. So we're going to have our 1/2 times -2 squared plus 1 times -2. That's not a 2. That's 5. There we go. Minus 4. Here we get -4. Same thing with our -1. I'm going to come in here and I'm going to do the cheat code. And we get -9/2 or -4.5. When x is 0, we have our y-intercept. So I don't even have to type anything in for 0. It's right here. It's -4. And when we type in the 1, we're going to get the exact same thing we did on the top, which is -2.5. So it's just kind of brute forcing our way through. So we have now to plot our points. We have -3, -2.5, which is somewhere in here. -2, -4. We love a right on it point. -1, -4.5. So in between, right about there. Got my 0, -4. Make that bigger. And 1, -2.5. And we can see our dots right here. When I connect them up, I'm going to go from one side to the other. I'm in this case going to go from left to right. Whoop, not like that. So we're just going to go swoop. Oop, I missed one. Let's try it again. There we go. Something like that. So these graphs are going to come around over and over and over again. We're going to be working with parabolas for a long time. They're going to come up in a lot of things. So it's good for us to be able to graph from this form without having to do things to change it to the other pieces. Okay. So what we're going to talk about today is we're going to start with solving some of these quadratic functions. So that means you need to get your notebooks out. So I have up here on the screen our general form again so that we could see it. Because we're going to talk about solutions, and some of them relate to our standard form. Honestly, it's not the easiest way, but we're going to start with it. So one thing we need to know is what the heck is a solution when we're solving a quadratic function. The word solution has 4 synonyms, or 3 synonyms, so there's 4 words that mean the same thing. So solutions are the same things as roots, which that doesn't really help us see what's going on here. This next one is going to be really helpful. It is called the x-intercept. Or it can be called the zero. All 4 of these words mean the same thing. So if we take that graph we just made in the bell work, where it looks something kind of like this, our solutions are the x-intercepts. Those are our roots. Those are our zeros. Those are the solutions. These guys are going to be what we're looking for here. When we're working with something in standard form, our options are going to be to graph it. And that's what we're going to do today. Today we're going to take these and we're going to graph them. So just like we did in the bell work, we'll take these and graph them. So the reason that they're called zeros is when we're working with equations like this guy up here, what we're going to do is we're going to set it equal to 0, and then we'll solve it to get whatever x equals. And we can do that by graphing. We can do that with a couple, I was going to say about 3 other ways of solving it. There's lots of ways to do this. But today we're going to focus on graphing, which means I should probably get you guys some graphs. Okay, but those 4 words, that's really important. You guys need to have that marked down. Okay, so mark down those 4 words. Okay, these are the times. Okay. Oh, no, not those. Where's these? I don't know if I have enough of these ones. We're going to give you guys some graphs. We're going to do 3 today where we're going to find solutions. I should have 3, so I'm going to give you guys 2s and 1s. All right. So this is our first one, and they gave it to us in a really weird order. Not super helpful. So we're asked to solve, we're asked to find our solution, find our root, find our 0. So what we need to do first of all is we need to get this thing in the right order so that I can actually graph the dang thing, which means I want my ax squared plus bx plus c. So I need to get everything on the same side of the equal sign. So what can I do to get this stuff to all go to the same side of the equal sign?
Subtract 10.
Yeah, let's subtract 10. What else needs to move? More specific. Because we need to add the x squared. That's going to give us a 0 equals x squared plus 4x plus 4. And this is what we're going to graph. We'll treat the 0 like it's our y, because it is. But that's what we're going to graph. So just like we did on the bell work, we're going to make our big old table. We're going to pick some x's to find our y's so that we can graph the dang thing. Which means I need to start with my axis of symmetry. I want my negative b over 2 times a. What is our b value here? 4. What's our a? Is 1. Because it's the number in front of my x squared. If there's nothing written there and it's multiplied, it's a 1. So negative 4 divided by 2 is negative 2. So that's what goes in the middle of our table. Our axis of symmetry always goes in the middle, negative 2. It's going to give us our vertex. That is what the axis of symmetry does for us, is it finds the vertex, it finds the middle. Then we're going to pick a couple of numbers bigger, like negative 1 and 0. We're going to pick a couple numbers smaller, like negative 3 and negative 4. And we're going to substitute those into our calculator, into our equation, to get our points. So we'll start with the negative 4. We're going to take negative 4 squared plus 4 times negative 4 plus 4. And we get the point of 4. Lots of 4s there. We're going to do the same thing with the negative 3. Negative 3 squared plus 4 times negative 3 plus 4. And we get 1. Same thing with the negative 2. Negative 2 squared plus 4 times negative 2 plus 4. And we get 0. Same thing with the negative 1. We're almost done with this one. We type it in and we get a 1. So once we get to this point in our table, it's kind of plug and chuggish. We're taking the x's we found through our calculations and typing them into the calculator, because calculators are a wonderful tool for us to use. Our last one, our 0, we don't have to type in. You can if you're in a groove, but the 0 is always going to be our c value, so it's going to be 4. That's going to be our y-intercept. So then we're going to plot our points here. I have negative 4, 4. I have negative 3, 1. Negative 2, 0. Negative 1, 1. And 0, 4. So there's our graph. Now we're asked to find where is our solution. Where is our solution? Root x-intercept. Those are all synonyms, remember? So where is our solution? It's at negative 2, 0. That's exactly right. So our solution is the point negative 2, 0. We will sometimes wind up with one solution. We will sometimes wind up with no solutions. We will sometimes wind up with 2 solutions. So make sure you look. This one has one solution at negative 2, 0. Yes, dear. When it's on the axis, where it hits this line here. I gotta watch it. So wherever it crosses this axis is where our solution is. We're going to try that again. Don't worry about it. We will solve another day. All right. Let's look at the next one. The next one is kind of story problem-ish, and those always get scary. It's okay, though. So what we have here is it feels like a system of equations. It feels like we took a step back in time, but it's okay. Because we've got the sum of 2 numbers is 14. So if I said x plus y equals 14, and x, the product of the 2 numbers, x times y equals 45, the product of the numbers is 45, we can kind of do the substitution thing like we did in the last chapter. I can take this guy and make it be an x equals or a y equals. I'm going to make it be y equals because it's way more familiar. Y equals 14 minus x, right? If I know y is the same thing as 14 minus x, can I not substitute that in place of this y? X times 14 minus x is 45, right? Then we're going to simplify this. I'm going to distribute my x through. 14x minus x squared equals 45. Now that looks significantly more familiar. Now this looks like a quadratic. Before we're going, wait a minute, where did we teleport to here? Now we're into exactly what we saw before, where we have to solve this and get it to be equal 0. So I'm going to add x squared to both sides. And I'm going to minus 14x from both sides. I'm doing that simply because I would rather have a positive x squared than a negative x squared. If you're ready to rock the negative x squareds, that's totally fine. But we're getting 0 equals x squared minus 14x plus 45. And that's the one we're going to try and graph. That's our guy. So the setup on this one is kind of obnoxiously long. From here, we're going to do our same thing that we did before. We're going to find our axis of symmetry. Negative b over 2a. So the opposite of negative 14 becomes positive 14 over 2 times 1 over 2. What's our axis of symmetry? 7. I'm going to give myself some more space here, but it's going to make my screen do a big jump. There we go. So what that 7 tells me is that's what's going in the middle of my table. I'll pick some numbers bigger, 8 and 9, and some numbers smaller, 6 and 5. And we're going to type them into the calculator. So I'm going to start with 5. So we're going to go with 5 squared minus 14 times 5 plus 45. And we get 0. Let's do the same thing with 6. 6 squared minus 14 times 6 plus 45. And we get negative 3. So then we're going to have 7 squared minus 14 times 7 plus 45. And we're just plugging and chugging this into the calculator here. Calculators are our very best friend. We're going to use them all the time. So we get negative 4. Same thing with our 8. 8 squared minus 14 times 8 plus 45. Can you do this without a calculator? Of course, but we don't have to. So we get negative 3. And then again, when we do 9, we'll see that it has a 0. and we're going to plot our points. We've got 5, 0, 6, -3, 7, -4, 8, -3, and 9, 0. And our parabola looks kind of like that. And we're looking for our solutions, our roots, our zeros. Where do we have solutions? Where does this graph cross our x-axis? At 5 and at 9. So my solutions are at the points 5, 0 and 9, 0. We can see that in the table, and sometimes we can, and that's amazing, at 5 and 9. So we're looking for where our graph crosses or hits the x-axis. And sometimes it'll hit right on a dot. Okay, let's do one more. Last one for today. And this is probably the hardest one. They at least give it to us in the right order this time. They at least give it to us in the right order this time. And so what we're going to do is we are going to graph it just like before. We're going to find our axis of symmetry. That's our place to start. So we're looking for our opposite of B. Our B here is 3 over 2 times A, which is -1. So what we wind up with is 3 halves, or 1.5. Gross. So what we're going to do is when we go to our table, we're going to pick some nearby points. If you want to do the 1.5 to get your actual proper vertex, that is great. We don't have to. Our axis of symmetry tells us 1.5 is the middle. Which, since we're using calculators, we can absolutely do that. But we don't have to. We can just use 2 and 3. We can go smaller and hit 1 and 0. And that'll be enough to get us a graph. You can also type it in. When we have x as 0 as an option, we can always take the shortcut of that one should be a 7. That's going to be our C value. Everybody else we are going to plug into our calculator. We're going to use for our opposite of x squared plus 3x plus 7. So let's do 1. The opposite of 1 squared plus 3 times 1 plus 7. And we get 9. We can do the 1.5. Since we're using our calculators, we can absolutely do that. 1.5 squared plus 3 times 1.5 plus 7. Like, totally a thing. 9 1/4. We can do that. But we don't have to, like, live in the world of decimals the whole time. 9.25. So we can do that, and we can put that there. We just don't have to live in the world of decimals. You don't have to count by half just so because it's going up by half. We can go to some whole numbers nearby, and you don't have to use these. You could have gone out a little farther if you wanted to. Let's do 2 and 3, and then we'll plot this up and see what's happening. So we have the opposite of 2 squared plus 3 times 2 plus 7. And we get 9, which is good. That means we are at symmetrical data right now. If we see that these guys match, that means that these guys are going to match. But let's do 3 just to double check, make sure we did it right. Opposite of 3 squared, did it the hard way, plus 3 times 3 plus 7. Yeah, we got 7. So we're going to plot our points. We've got 0, 7, 1, 9, 1.5, and a half. So it's real, like, meh, real close there. That's our vertex. 2, 9, and 3, 7. It's gross, and that's okay. A lot of parabolas are a little bit gross. And so what we're going to get is something that looks like this. Ooh, that was terrible. And we get roots that don't hit properly. Like, they're not hitting at the right spot. We got something that's in between. They're not right at a dot. And that's okay. We're not going to get super specific, and we're not going to guess. We're going to say that we have a solution between so here it's going to be between -2 and -3. So between x equals -2 and x equals -3. We have another solution between x equals 4 and x equals 5. Oops, I erased part of my x. So if you don't get a proper point, that's okay. It can be in between. We are not going to go ahead and and estimate decimals. We're just going to say it's somewhere between them. And we're calling that good enough. We will have ways to calculate gross decimally ones later. Okay? More often than not, they are going to hit on proper points because we are just not jerks like that. But sometimes the book goes a little crazy. And so I wanted us to see that and see what that looks like. Okay? So I am going to pass out homework 3-2. It has 4 graphs for you to make, 3 graphs for you to read, and 4 graphs for you to read. Okay? So these first 3 are just where is the solution. You can circle it and just write them out. Okay? So there's 3-2. Our quiz over this chapter, where our first quiz is next Friday, week from tomorrow. And you guys have about 4 minutes until announcements start.